So thermal physics structure questions, as we discussed the first 8 pages. This one is page number 9. As you can see, an electrical heater is placed on the floor of a room. The heater is switched on. State the main process by which the thermal energy is being transferred to air in all parts of the room. So what is the main process by which the thermal energy can transfer? Because they're talking about air through air. So we discussed yesterday that in fluids, the method of heat energy transfer is known as convection. So in fluid, convection happen like the as a result, when group of particle absorb heat energy, they move away from each other and density decreases. That group of particle will rise and another group of particle will move down. That will set up a convection current. The next question, the heater has a power of 1.5 kilowatt. So the power is given, the unit of a power is watt. So you have to convert 1.5 kilowatt into watt. You have to multiply by 1000. So it will be 1500 watts. The mass is 65. The specific heat capacity, that is C, is given. Calculate the time it takes for this heater to raise the temperature from 8 to 15. Like how much time it will take to increase the temperature of a air from 8 to 15. So how to solve this question? First, we'll find how much energy is supplied or how much energy is being absorbed by the air. So using a formula, E equals Cm delta T, the specific heat formula. Specific heat of the air, that is given 720. M is the mass of the air, which is 65. And the temperature changes from 8 to 15. So it will be 15 minus 8. That will be the temperature change. So E is equals to Cm delta T, multiply all of them. You'll get how much energy is being absorbed by the air. What's the answer for this? 720 times 65 times 15 minus 8 means 7. What's the answer for this? How much energy is being absorbed? When you multiply all these three factors, it is 32,760 joules. Okay. So the energy which is being absorbed, it is 32,760 joules. Now, okay. This is one more zero is there. I thought 32,760. So it is 327,600 joules. Okay. Now we get the energy. We need the time. How much time it will take to supply this much energy? So we have the formula that power is equals to energy divided by time. So the power of the heater, that is in watt, which is 1500. The energy which we supplied, that is 327,600 joules. And we need the time. So we need the time. So we just cross multiply. So the time will be equals to 327,600 divided by 1,500. When you divide, what answer you will get? That will be in second. What's the answer? 327,600 divided by 1,500. 218.4. So we can say 218. So we can, because like three significant figure, whenever you write your answer, you should always, the final answer, don't try to round off your answers in between. The final answer should be in three significant figure. So we write 218 seconds. So this will take about 218 seconds to supply the heat energy so that the temperature of a room increases from 8 degrees to 15 degrees. Is it clear, this one? Anyone having a doubt or a question in this? Okay, okay. On page 10, state two reasons why the calculated time is smaller than the actual time. Like for example, so we have the room and it have a 65 kilogram of air inside the room. 65 kilogram of air is inside. We use a heater with a power of 1.5 kilowatt, and to increase the temperature of the air from 8 to 15 degrees, we need about 218 seconds. That is what we calculated in the previous part. But they're asking why practically, like the reason why the time calculated is smaller than the actual time. Like practically, it will take much more or much longer duration to increase the temperature from 8 to 15. Like it will take much longer time, like more than 218 seconds to increase the temperature. So what might be a reason? What do you think about the reason? So if you consider, that's a good answer. If you consider, we think that this room is just completely filled with air and there is no loss of energy. But practically, what might happen when the air particles become hot, hot air is rising up, so it will come in contact with the wall and it will lose energy to the walls. So as a result, what will happen? Some of, and heater is not providing all the energy. And another thing, what we assume here, we assume that all of the energy from the heater is supplied to air, but in practical what will happen, the heat energy is supplied to walls as well and to the ceiling as well, to the floor as well. So two reasons are, and again we did not consider any furniture or object is there in the room. We consider that the room is just filled with air. So practical reasons why the practically it will take much longer time. First is the heater does not, like heater supply energy to the surrounding as well. Not only like all the energy transferred to air, some of the energy is transferred to the ceiling, to the floor, to the walls. That is one reason. And some of the energy transfer from air to outside. So as a result, it will take much longer duration. So the heater energy is absorbed by the walls, floor, ceiling. That is one. And the second reason is that like the air lose energy to the surrounding. Like once air will become hot, not all of the energy of the air is being like used up. Some of the energy of the air is lost to the surrounding. That's why when we supply the heat, like it practically it will take much longer time than the value which we calculate. So page 10, then we have, this is also in figure 7.1. You have to, arrows are representing the state, changing state. State, change of state at X is from dash to dash and Y. So at X, what is the change in state here in X? Which form has converted into which? Yeah, so solid is converting to liquid, that's right. Good. And the other one is the liquid is turning into gas. So the first one, the solid has turned into liquid. And the second one, the liquid has turned into a gas. Explain in terms of forces between their molecules why gases expand more than solid and when they undergo the same rise in temperature. Like when we supply the equal amount of energy, say we have equal amount of gas and a liquid, when we supply equal amount of energy to both of them, the expansion or the increase in size for a gas is much higher as compared to expansion in a liquid. So we have to explain in terms of the particles. So what happened? In liquids, the particles are closer to each other, so they have a strong attraction. But in gases, the particles are far from each other, so they have a weak attraction. So as a result, a small amount of energy can move the particles away. So the distribution, how you will score the marks for this? One is a comparison between the forces, spacing and the forces. Liquid particles are closer and strong force between the particle. In gases, particles are far from each other and they have a weak force. So small amount of energy move the particles of the gas further away. This one is page 11. The next is, this is related to the gas laws, the Boyle's law. A cylinder of volume 0.012. So we have the volume V1 containing a compressed gas at a pressure of 1.8 exponent 6 Pascal. So that is the initial pressure P1. The valve is open and all the compressed gas has escaped from a cylinder into atmosphere. The temperature of a gas, look, these type of questions, how you'll identify that you have to use a Boyle's law, which is P1 V1 equals P2 V2. So how you know that you have to use this formula whenever there's a like question is related to pressure and volume and the temperature does not change. So calculate the volume of the escaped gas. How much gas has escaped? Look, I'll draw a diagram here. It's even though it's not shown, but I will draw. You have a container, okay? The container has a volume of 0.012 meter cube. And the pressure of the gas which is inside, like there are gas particles, the pressure of the gas inside is 1.8 into 10 to the power 6 Pascal. Now what happened? The valve is open. So one side we open the valve. I'll draw another figure to explain the idea. So the valve is open and the gas escape. But when we say the gas escape, it's not like all of the gas will escape. Some of the gas will go out, and it will go out until the outside pressure and inside pressure is same. Because when the outside and inside pressure is same, then the gas particles are not able to move out. So means that what is the new pressure of the gas? The outside pressure, the atmospheric pressure is 1 into 10 to the power 5 Pascal. So if 1 into 10 to the power 5 Pascal is outside pressure, what is the pressure of the gas inside? That should also be 1 into 10 to the power 5 Pascal. When outside pressure and inside pressure is equal, then the gas will stop moving out. We have to work out, in the question, we have to work out what volume of the gas has escaped. So first what we'll do, we'll use a formula like P1 V1 equals P2 V2. And we'll find what volume of the gas will be there in the cylinder. Like we know what is the initial volume, but we'll find when the pressure of outside equals to inside, how much gas will be there still present. And to know how much gas has escaped, we just subtract the two volumes. So we use a formula P1 V1 equals P2 V2. The first pressure was 1.8 into 10 to the power 6. The first volume was 0.012. The second pressure is 1 into 10 to the power 5 Pascal, which is atmospheric, and we'll find V2. One exponent 5 is multiplied, other side will be divided. So it will be 1.8 into 10 to the power 6 times 0.012 divided by 1 into 10 to the power 5 Pascal. This will give us how much gas is still there in the cylinder, which is 0.216. Okay. 0.216 meter cube. This is a gas. Now we know that 0.216 is a gas which is still there. So how we'll know what volume of the gas has escaped or what is the difference in the volume? So you have to subtract. So you have to subtract the two volumes. Like this is a final volume, this was the initial volume, subtract the two volume, and this will give us how much gas has escaped. Is it clear, this one? Page 12. So page 12, you have to complete the sentence with a word that describe the main process of thermal energy transfer in each case. A man goes for a walk on a cold day. He touches a metal gate, which remove the thermal energy from his hand by, like if you touch anything, how the energy will transfer from your body to that object or that object to your body, how the energy will transfer. Good, that's good, Rabia. That is conduction. So the first thing what will happen is a conduction. He holds the sides of a cup containing a hot drink. His hand gain thermal energy by, like he is holding a hot drink. How his hand will gain energy? By which method? He is holding. Like again, he's in contact. Like his hand, you're in contact with. Whenever you're in contact, how the energy will transfer? Conduction again. So whenever two different objects are in contact, how the energy will transfer is by conduction. So this also conduction. Then some farm workers have lit a fire. The man warmed his hand by the side of the fire. Like example, some farm workers, they lit a fire and the man places his hand sideways. By which way he got the energy transfer? His hand gained thermal energy by radiation. That's right. Describe in terms of the particles the transfer of thermal energy through the metal of the gate after the transfer from the man hand. Like example, you have to explain, actually you have to explain conduction here. So how the conduct, because like the man touches the metal gate, the energy transfer, you have to explain how the energy transfer within the metal. So what will happen within the metal? The energy transfer by lattice vibration and movement of delocalized electrons. That's how the energy is being transferred from the man hands to the metal door. The next, in this question, figure 5.1 shows a car on a sunny day in a hot country. The windscreen is there and the object A, like usually the screen protectors are, the sunshades are there. Then they're saying the object label A is placed inside the windscreen and it is used by the owner of the car to reduce the temperature rise of the air inside the car. Ring the most suitable material for the outer surface of object A. You can use a screen annotation like what should be this type texture of this surface. Should it a dull black, a dull white, a shiny black, or a shiny white? You can annotate on the screen. What should be this? We want to protect it from heat. We want it to absorb less amount of heat or reflect most of it. You can use screen annotation. Annotate on the screen. There's an icon you can see on this on your toolbar. So what should be the? Yeah, that's right. So it should be shiny white. And reason for that, reason for having a shiny white. So explanation. What is explanation? Because the shiny white surfaces are good reflector. So reason, it's a good reflector, so it will reflect most of the heat energy. As a result, the temperature of the air. That's why the sunshades, which we normally use here, very common. In summer, it's more common as compared to that in winter. The main reason is that so it will reflect maximum amount of thermal radiations to the surrounding. So the inside temperature will be much lower. Question, this is from page 13. So we have, in terms of momentum, as I mentioned here, a 4-mark question. In terms of momentum of molecules, explain how gas exerts pressure on the wall of container. So how gases exert pressure? So in terms of momentum, we have to explain this. So first thing when we'll mention gas molecules are moving randomly. They are changing the direction. So that change in momentum, because of change in momentum, they exert force, and force acting on unit area create pressure. So gas molecules are moving randomly, collide with the walls of container, changes the direction and the momentum, and the change in momentum exert force on unit area, which will create pressure. These are the points which we mentioned. How you'll score the marks? I'll mention like the mark distribution. 1 mark when you mention molecules strike the wall. So if I include molecules are strike, because sometimes they are give the mark for random, sometimes for striking wall. So molecule move random, collide with the wall. This will score 1 mark. Momentum changes the direction or changes the momentum will score another mark, the second mark. The change in momentum exert force, third mark. And force on unit area create pressure, that's a fourth mark. So try to learn this answer, this is a structured answer and a very common question repeated. So we have to relate by the like equation. We have the formula P1 V1 equals P2 V2. We need P2. So it will be, if I need P2 as a subject, so it will be P1 V1 divided by V2. That will be the equation for this. Like we don't have to find anything. We just have to make subject as P. In page 14, state and explain how the final temperature, how the final pressure compare with P2 when the temperature has increased. If we increase, like example, if we increase the temperature, what will happen? The pressure will also increase. So the final temperature will be greater or higher. And what is the reason for that? Because the particles or the molecules will move faster, exert more force, or greater change in momentum. As a result, it will exert more pressure or a high pressure. So this is what you have to include. So this is about the thermal physics, like we did the first 14 pages. More we'll do time to time. We'll do more from this